Hello everybody, welcome to this 7th lecture session of the course Database Management Systems. In this course, we will have detailed discussion about the structured query language, which is a commercial query language for relational database management systems. And all the present days commercial vendors for RDBMS, that is Oracle or Ingress or Informix, whatever it is, all of them they support this SQL. Using this SQL, the end users can pose queries or questions to the database with an intention to retrieve the data from the database or to manipulate that data from within the application program or whatever it is. In this session, we will have a brief introduction to SQL, we will have a look at the history of SQL, then we will start discussing about the various important and then excellent features supported by SQL. We look at the DDL commands, that is data definition language statements that are supported by SQL, and then we will start discussing about the DML, data manipulation language set of statements. If we look at the brief history of SQL, we in the previous classes, in the previous sessions, we understood that not just storing data in the database, at the same time we need to have facilities to retrieve or extract data as and when it is required by the end users or the application programs. That is why every data model should have query languages, and we can classify the query languages into two categories. The first one is the formal query languages, and the second category could be the commercial query languages. As far as the relational data model is concerned, in the previous session we discussed two important formal query languages. First one is relational algebra and then relational calculus, tuple relational calculus. These formal query languages, only experts can pose queries to the database or specify their data retrieval requests using these formal query languages. They are not end user friendly and they have strong mathematical background. It is not that easy to write or specify queries using these formal query languages. That is why, to make the life of the end user simple, all database vendors and for every data model will come along with a commercial query language, and which becomes easy for the end users to specify their data retrieval requests or queries. Similarly, for relational data model, SQL is considered to be one of the most popular and most used commercial query language. Nowadays, it has become a standard for all commercial database management systems which are based on relational data model to support this SQL query language. And this SQL query language is almost like our English language, hence the end users can write their or specify their queries with ease. This SQL structured query language was initially called as SQL, Structured English Query Language, and then it was designed and then implemented at IBM Labs for their experimental relational database management system called System R. This System R was an experimental RDBMS, and to pose queries to this RDBM database, they have implemented and then designed and implemented this SQL language, and then later it is known as SQL, and it has become a standard for commercial relational database management systems. Then joint effort of ANSI, that is American National Standards Institute, and then ISO, that is International Standards Organization, it has led to the standardization of this SQL specification, and first version of the standard version, first specification of SQL was released in 1986. Then the second version was released in 1992. The current standard of SQL is called as SQL 3, or otherwise we also call it as SQL 99, which was introduced in 1999. These ANSI and ISO are the standards organizations which take care of standardization of this SQL specification. And one important thing to be noted is SQL is a specification and I can implement SQL in my own way, but as far as I conform to the rules or the guidelines specified given in the specification of SQL, then I am done. That's why all commercial vendors, they adopt these SQL standards and then specifications and then implement SQL in their own way. SQL is the most widely used commercial query language for relational databases. SQL was introduced in 1970 by IBM. The present standard of SQL is SQL 3, or it is called as SQL 99, was introduced in 1999 by ANSI and ISO. SQL is a user-friendly query language. Nowadays, almost all relational databases like Oracle, MySQL, IBM's DB2, Informix, they support SQL. SQL is a high-level declarative language. In the previous class, we understood that a language can be declarative or procedural. Declarative means non-procedural. That means using that query language, we can just specify what we want to extract from the database, what data we need, what result we need, rather than specifying how it can be extracted. So that's why we have the procedural languages and then non-procedural languages. And relational algebra is a procedural language because we specify series of relational operations to extract the data or retrieve the data from the database, whereas the formal query language, the tuple relational calculus, we understood that it is a non-procedural language because we just specify what we want from the database. That's why it is called as a declarative language. Similarly, SQL is also a high-level declarative language to specify data retrieval requests for data stored in relational databases. It is not procedural, and it is declarative because we just specify what to be extracted rather than how it should be extracted. That's why it is non-procedural, or we call it as declarative. SQL is relationally complete, and this notion of relational completeness is also discussed in the previous class. It is the way we can assess the quality or expression power of a query language. Suppose if there is a language L, it is called as relationally complete if I can write all the queries whatever I can specify using relational algebra or TRC in the given language L, then I can call the language L as relationally complete. And we coin a statement saying that SQL is relationally complete, meaning that any query that is expressed in relational algebra or calculus can also be written in SQL. And apart from this, the features supported by these formal query languages, SQL also supports additional features that are actually not existing in formal query languages, like transaction management, so creating indexes, so on and so forth. SQL is a standard and many vendors implement it in their own way without deviating from the standard specification given by the standards organizations ANSI and ISO. That means we are free to implement SQL in our own way. As long as we are not deviating from the standard specification, we are done. That is a valid implementation of SQL. All commercial vendors, they support SQL and they implement SQL standards in their own way. Let us have a look at the features that are supported by SQL. It supports, if you look at the statements or commands that can be written using SQL, that can be divided into two categories. First one is the DDL kind of commands, second set is the DML commands. These are the two important classifications. The first set is data definition language. DDL stands for data definition language, and it comprises of set of commands to support definition of the database, that is defining the structure of the database, creating tables and deleting tables, altering the structure of the tables, and then defining the constraints, so on and so forth. That is, using this DDL set of commands, we can define the structure of the database. And the other set of commands are called as DML commands, data manipulation language. Once you are done with the definition of the structure of the database, then we can store data into the database and we can insert new tuples, we can update the existing tuples, or as and when needed, we can delete the existing tuples, or we can just query or extract the data from the database by using these DML kind of commands. And it also supports embedded SQL, meaning that it allows users to call SQL code from host languages like C, C++, Java, PHP, so on and so forth. That means I can write application program using some programming language like Java, and then our programming language or our program written in some language can interface with the database and then extract data or manipulate data, and this is supported by the feature called as embedded SQL. Of course, we will be using some drivers. Through these drivers, we will be able to interact with the database. That means we are able to write SQL commands or SQL queries, specify them within our program, and then take help from some drivers, and then these SQL queries can be sent to the database management system, and the required result or required action can be performed. That is, the manipulation or data extraction can be done using this embedded SQL. That means we will be able to embed the SQL commands into our programs written in our C, C++, Java, so on and so forth. That is the advantage of SQL. Then SQL also supports triggers. Triggers are nothing but actions executed by database management systems whenever changes to the database meet specified conditions. Actions to be performed and the set of conditions that will trigger the action can be defined as part of the triggers. Okay, that means if at all there is a change, for example, let us assume that there is an employee table and it has employee ID, name, and then salary, and if at all there is a change to the salary of any employee, I would like to take certain action, then I can specify the event that is going to trigger the action, and I can also specify the operations or action that need to be taken when that specified condition is met, and both of these things, that is the condition that need to be satisfied and the actions that need to be performed, can be defined or can be written as part of a trigger, and that triggers will be part of the database management system, and whenever changes to the database meet specified conditions, these actions will be performed, and that is going to do some operation. Then the SQL also supports transaction management. That means I can start a transaction, I can roll back a transaction, I can commit a transaction using these SQL commands. At this moment of time, let us not worry too much about what exactly the meaning of this rollback, commit, and then all these things, and then let us defer the discussion until further time when we have a dedicated discussion about the transaction management. Then we will see in detail about all these concepts. Then it also supports indexes. That means the using SQL we can specify the indexes, or indexes can be built on some tables which will facilitate easy and then fast retrieval of the records from the database for end user or for the application programs. So these are the very important. Of course other features are also available, but these are the very important features of SQL. Now we understood that using DDL set of commands we can define the structure of the database, meaning that what? Define the structure of a table, we can define the format for attributes, we can specify the constraints like null, not null, default constraint, and then unique constraint, primary key constraint, foreign key constraint, and the structures can be defined using these DDL commands. Now let us have a look at the important definition is a table definition, that is creating the structure of a table. That is, we use the keyword create table. This is the keyword because SQL is also a language. If you look at any programming language, they will have a set of keywords. That means these are called as reserved words. That means the end programmer cannot use these keywords as identifiers in their programming language or in their programs, because the keywords, the compiler for that particular programming language, it has a specific meaning towards these reserved words or the keywords. That's why they cannot be used as the identifiers like variable names or table names or attribute names. That's why create is a keyword and table is a keyword. I need to use these standard keywords when I am defining the structure of a table. Create table, then this is an identifier. That means whatever name I wish, I can give that name. Here in this case I would like to make it employee table, and then we need to start with a parenthesis, left parenthesis, and then we can start listing all the attributes or fields of the table. First field is going to be fname, and then immediately a space, and this is an identifier. It can be of the choice of the programmer. Then there is a space, then varchar 15, which is a keyword, which is a variable character string 15. That means it can take up to 15 characters, and a space I can specify whether the value under that column can be null or not null. If it is not, by default it can take null, and if I want to make it not null, then I need to explicitly specify not space null. It is also a keyword. Then the definition of first attribute is over, then I need to end that with the attribute definitions will be separated by commas. So that's why put a comma there and then go for defining the second attribute, middle initial space character, meaning that what? It is of type character, it takes only one character, and then put a comma, then so on and so forth. I can specify all the attributes of the table employee or relation employee. Then if you carefully observe here, and here there is a type called as decimal, which will go up to 10 digits. Out of 10 digits, last 2 digits are going to be for representing the fractional portion of the number. Then fractional portion of the value. Then if you carefully observe, there is a attribute called as DNO, which is of type integer and which cannot take null, and at the same time I have also associated a default value here for that attribute. That means we have understood what is the meaning of this default value. Suppose there is a employee table which has department number, and then I have department table which has a dnum, and this is a primary key, this is a foreign key pointing to this attribute. Suppose if I am deleting something here, then in the previous session we understood that I can specify that the value under this column for which I am updating, for which this tuple is referencing this tuple in the parent table, if there is a modification or change to this value under dnum, then what should happen to the corresponding value under this foreign key attribute? That can be set to null, or that can be set to default, or it can be a cascading action, or it can be a restriction, that is I need not allow. That is, if at all it is set to take a default value, then which is the default value? Then if I specify a default value at the time of defining the attribute, then whenever there is a change in the parent tuple in the parent table, the corresponding tuples under in the dependent table under the column of the foreign key, the value will be set to this default value. That is the meaning of this default value for the attribute DNO. Then that means up to this it is defining the attributes. The list of attributes are separated by commas. Then immediately after a comma I am going to specify the foreign key constraint for the table. Primary key constraint. What is the keyword I am going to use? Primary space key. It is not a single word. There is a space between primary and then key words. Primary key parenthesis, I need to specify which is the primary key attribute for the table. In this case it is going to be SSN, so that is why it is the primary key. Of course in some cases what happens is more than one attribute is going to act like primary key for the table. In that case what we can do is primary space key. This is how we can specify this. And then suppose if the dependent name and employee ID are the primary key, then I can say that employee ID comma dependent name. The meaning of this is the attributes employee ID and dependent name together are going to act like the primary key for the table. Then the primary key is set for the table. Then let us understand that there is a foreign key in the table which is super SSN, which will indicate who is the supervisor of the given employee, and that references the same table. Let us assume that it is a unary relation and that references the same table. How to specify that? And same table, this will refer to SSN of the same table. So foreign key, there is a space between foreign and key words. Then in parenthesis I will write what is the foreign key. Super SSN is the foreign key in this table, and if you look at this it is going to be like this. If you look at employee table, you have so many attributes. One among them is SSN, and you have another attribute called as super SSN, and you have another attribute called as DNO. Super SSN is a foreign key pointing to SSN, which is primary key of the table, and then if I have department table and if I have D number, then DNO is a foreign key pointing to this. So that is why first I am defining the foreign key attribute super SSN. Foreign key super SSN references, it is a keyword, space, which table? Same table. That is why employee table. Which attribute it is referring to? It is referring to SSN attribute. This is how I can specify, that is I am specifying this foreign key using this statement. Then comma, I have one more foreign key in the form of DNO attribute in employee table. So hence foreign space key in parenthesis which is the foreign key, DNO is the foreign key, and space references which table, it is going to refer to the department table, department, and then in parenthesis which attribute in department, D number attribute, which is a primary key of the department table, is being referenced by this foreign key DNO. This is how we can specify the foreign keys and then primary keys. And sometimes what happens is, to do this, if you carefully observe, there are two tables, employee and department. There are certain foreign keys. Of course, super SSN is a self-referential, that is, it is referring to the same table. But the DNO in employee table is referring to department table. Now, which is the parent table and then which is the dependent table? Department is the parent table, which is referenced by some tuples or some foreign key in the employee table. That is why, to define the structure of the employee table, we need to first create the department table, because if you do not have a department table and then if you write this kind of statement, that is foreign key DNO references department table, then it gives an error, because it says that there is no table or relation with name department. So that is why it is an error. To make this possible, first I need to define the structure of department table, and then I can specify this creation, that means definition of employee table. Sometimes what happens is, for example, I have employee table. Of course, I have given a simplified version of employee table and then department table. In this particular example, they are going to have 4 and 2 attributes respectively. Employee has employee ID, employee name, age, and then DNO. Employee ID is the primary key, DNO is the foreign key pointing to department table, DNUM. DNUM is the primary key, and then DNAME is the another attribute. Then if you look at the domain or format, EID is of type integer, and ENAME is of type string, and age is of type integer, and DNumber is of type integer. Then DNUM is integer, DNAME is string. Now since DNO in employee table is a foreign key pointing to DNUM in a department table, that is why the domain of this foreign key attribute and the reference attribute must be same. Then only I can set this foreign key. And in this case, both are going to be integer only. That is why I can specify the foreign key constraint. Now, here if you carefully observe, department table is not dependent on employee table, but there is a attribute in employee table which is DNO, which is a foreign key pointing to DNUM in department table. Hence, it is a dependent table and it is a parent table. We can consider it like this for the sake of better understanding. If such is the situation, which table should I create first? And creating employee table first will not work. Suppose if I try to write it like this, for this kind of table structure or the schema for the relation, I need to specify the table creation like this: create space table. And one important thing to be noted is, SQL is not case specific. I can write the keywords or whatever it is in small case or capital letters. Both are same, both are valid. And create table employee, that is name of this relation, and I am defining the structure for this relation. Parenthesis, starting parenthesis, first attribute employee ID, integer type, primary space key. One important thing is, I can specify the primary key constraint when I am defining the attribute itself. It is also possible, and this is one way of doing it. In the previous case, I have defined or I have specified the primary key constraint after defining all the attribute at the end of the definition of the table. But here in this case, along with the definition of the attribute, that is EID, I know that for sure, I know that it is going to be the primary key. I have specified the primary key constraint, and then a comma, second attribute ename varchar 20 comma age, it is integer, and then DNUM DNO, it is integer. Then I try to specify, I want to make this as a foreign key. So foreign space key, which is the attribute DNO, references which table? Department table, and then what is the reference attribute? DNUM. But this gives an error, because when this is executed, when this is passed, it understands that the department table which this table is referencing is not existent. That is why it is an error. In this situation, first we need to create the structure for the parent table, then we should create or define the structure for the dependent table. Hence, first we need to define the structure for parent table department. Create table, that means I am defining the structure for this relation. Create table department parenthesis, DNUM is the first attribute, and then integer type not null, and DNAME varchar, and 10, that means maximum it can take up to 10. Then I am specifying the primary key, primary space key, which is the primary key attribute dnum. This is how I can specify the structure for the table department. Once it is done, once it is successful, then I can write this statement, this is going to work, because when it is referencing this particular department to define the foreign key or specify the foreign key constraint, then of course the department table is already existent, hence it will not create any problem, there won't be any error message for you. Sometimes what happens is you will be trying to creating two tables which are dependent on each other. For instance, if I consider this second example, I have employee table and department table with respective fields, employee ID, e-name, age, and then DNO, which is a foreign key pointing to dnum, primary key of the department. Then I have dname in department and then manager, which indicates who is the manager of the department. And here DNO is a foreign key pointing to this, and then manager in department table is a foreign key pointing to primary key EID of the employee table. Then both are dependent, both are, there is circular dependency is there. That means this table in terms of foreign key, it is dependent on department table, and department table is dependent on employee table. When there exists a circular dependency in terms of referential integrity constraint, then which one need to be created first? It is a problem. If I try to create the employee table first, it will say that when I am setting a foreign key DNO, it says that department table is non-existent. Otherwise, if I try to create department table first, when I am setting the constraint manager, it clearly says that the employee table is not existing. So hence it is a problem. In that case, to solve this or to alleviate this, there is a possibility that first I can define the structure of the table without worrying about the foreign keys, and later once both the tables have been created, then I can alter the table structure by adding the constraints like foreign key or whatever it is at later point of time. In this case, what I can do is I can create the tables for employee and department. That means I can create this department table, it will not create any problem because primary key can always be set, there is no issue about it. Then I can create employee table completely, but without this foreign key constraint. Then it is done. I am done with the department table. That means the structure of employee table and the department table are already existing in the database definition. Then after that, I can think about defining the foreign keys. How I can do that? I can use the alter command. The create command is going to create the definitions for tables or whatever it is, constraints, whatever it is. The alter command can be used to alter the structure or definition of the table. Alter table, which table? Employee table. What way I would like to alter it? I would like to add a new constraint, add constraint, that is the keyword. And at the same time, one important thing to be noted is I can also attach or associate names, the user defined names or user given names to the constraints. Here in this case, the foreign key constraint I am going to set, and I would like to call that constraint by name EMPFK. It is an identifier, it can be given by the user. So I am adding a constraint with name EMPFK. Foreign, what type of constraint it is? It is a foreign key. Which is the foreign key attribute? DNO. References department table. Since the structure of department table is already existent, it will not create any problem. So what is the attribute? DNum attribute. Similarly, I need to alter the table department, add constraint. I can give a name to that foreign key constraint. What type of constraint? Foreign key. Which is the attribute? Manager. References employee table. Which attribute? The employee ID. That means when there is a circular dependency between two tables or relations in terms of referential integrity constraint, I can create the structures first with primary keys, and then later on I can alter the definition or structure of the table by adding the constraints. Foreign key constraints can be added at later point of time, and this way we can solve this problem when there exists a circular dependency between the tables. Of course, this we have already seen. Create table department, department name varchar not null, and d number integer not null, manager SSN character, manager start date, and a special kind of data type, that is date, is available to represent the date. format. Then the primary key, dnumber and unique, and if you carefully observe, this is how we can specify unique constraint, uniqueness constraint. By default all primary keys are unique only, but apart from the primary key, if you want to specify any attribute to be unique for different tuples, the value of a given attribute to be unique for different rows, then we can specify it using this keyword, that is unique. If I specify that unique dname, meaning that what? The department names cannot be same for multiple departments, that's why it is going to be unique. Then foreign key manager SSN references employee SSN. And similarly, as and when required, I can also drop a table, drop table EMP. And of course, cascade and restrict keywords can be used. Cascade means if you are dropping a table, if there are any constraints specified in terms of foreign key or whatever it is, all that constraints will be dropped. Suppose if I have employee table and then department table, and dnumber, dno in employee is pointing to dnumber in department table. If I try to drop department table, what should happen to this foreign key? If you say cascade, it will drop all the constraints that are involving this drop table. And if you say restrict, when there is a constraint that is specified on this table which you wish to drop, then the system will not allow you to do that. That is dropping a table. And similarly, since names have been specified or given to the constraints, I can drop the constraints whenever it is necessary. Drop constraint emp fk. So whatever foreign key constraint called emp fk has been defined in the previous case, that will be dropped. And as and when required, I can alter the table structure so as to add new columns. Alter table emp add, this is the name of the column and this is the data type of the column. And similarly, I can drop a column, alter table emp, drop the column age. I can use the keywords either cascade or restrict. If it is cascade, means it will, when you delete that, suppose if any other column or tuple is dependent on this column, then that constraint will be dropped, also be dropped. And if you say restrict, if at all this particular column which you wish to drop is involved in any constraint, then the system will not allow you to drop that particular column. We can also give names to the constraints, what we have seen, and later use the names to access those constraints with an intention to alter them, that we can do. First we have seen the DDL commands, how to create structures, how to alter them, and how to get rid of the defined structures using drop. Now we will see the DML commands, that is data manipulation language commands or statements, which basically intended to extracting or querying data from the database. That is the first and foremost purpose of these DML statements. Then inserting new tuples into the tables or relations or the database, updating existing tuples or deleting the existing tuples. All these things can be done using this DML statements. If you carefully observe, the DML commands, basic query statements in SQL, has select statement for retrieving information from database. Initially we will focus on the data retrieval or data extraction statements under this DML. So we have select statements. The basic form of select statement is going to be select what list of attributes you want to show up in the result, that will be given here. From indicates which tables you want to extract the data, where we can specify here the conditions that need to be satisfied by the tuples that are going to show up in the result. And one important thing to be noted is the select concept here in SQL is totally different from select concept in relational algebra, which is indicated by symbol sigma. There the select symbol or select operation sigma in relational algebra is going to extract subset of tuples, whereas select here is going to show or list the columns that need to be showed up in the result. So that is why the select here is totally different from select there in relational algebra. Select there in relational algebra is going to take the subset of tuples. The select clause here in SQL is going to show up subset of the columns in the result. So that is the difference. In select clause, the attribute names will be listed. in from clause the names of the relations from where the data need to be extracted will be listed, and in where clause we will specify the Boolean expressions to identify the tuples that qualify for showing up in the result. This is the basic structure of an SQL query statement. Of course, many variants are available and more complex queries can be written, that we will see in short while. The first thing is, if you carefully observe this example 1, select, it is a keyword, from is also a keyword, where is a keyword, and then remaining b date, that means I want to show up the birth date and address of employees whose first name is going to be John. Then how can I write that? Select the attribute values b date and address in the result, from which table? That need to be extracted from employee table. On what condition? If in employee table, if for each tuple, if the first name, the value under F name column is equal to John, for such tuples you please display the birth date and address column values, and in the result these are going to be the birth date and address is going to be the title of the fields or attributes, birth date and address. Retrieve the birth date and address of the employees whose first name is going to be John. Then we can also perform the join operation. Suppose if you want to extract some information by joining the tuples which are spread across more than one table, then I can specify this join operation in where clause itself. Let us have a look at this. I want to retrieve the first name, last name and address from the joined tuples from tables employee and department. The joining condition is the D number in the department table is equal to DNO in employee table, and we can also we want to figure out the details for the employees who are actually working with the department. D name is equals to research. That means for the research department employees, I would like to figure out the first name, last name and address. This is how I can specify. That means the first, whenever it is a data retrieval request is given, first we need to understand what tables or what data is required, then what tables need to be accessed, and then how to write the query and what features of SQL need to be used to specify the query. And here just a department table alone or the employee table alone will not solve our problem. We need to access, first we need to join the tuples which are spread across the employee table and the department table based on the DNO. Then we need to figure out or identify the tuples where the D name is equals to research. Okay, so this is the join condition for joining the tuples from EMP to department, and then this is the condition to be satisfied by the joined tuples to show up in the result. Once the tuples which qualify for the result are identified, then you select only F name, L name and address in the result. This is how we can write specify the join condition, or we can perform join operation by specifying a condition in where clause. Hence select F name, L name and address from which tables? Employee comma department. That means these two tables are involved in the query or involved in extracting the result for the query. Then from where, in where clause, first the tuples need to be joined where D number in department is equals to DNO in employee, then D name should be equal to research. This is the join condition. This is the condition to be satisfied. Next, select, I need to retrieve the employee's first name and his immediate supervisor's first name, and there is an example, it is an example of self joining. Select, that is if I am joining employee, that is I need to take two instances of the same table employee. If you have two instances of the same table employee, then you can give distinct names for these different instances. The first instance of employee table is called as E, second instance is called as S. Now select E dot F name, it refers to the F name of the first instance of the employee table. Then S dot F name, that refers to the second instance. And what is the where clause? From which tables? Employee as E. If you carefully observe, this is how I can give alias name to employee table, that is the first instance of the employee table is given a name E and comma second instance of the same employee table is called with name S. Then what is the where clause? Where E dot super SSN is equals to S dot super SSN. That means the same table I take two different instances, and then here I have SSN and then super SSN, here also I have SSN and then super SSN, and this is called as E and this is called as S. Now E dot super SSN, suppose if this is the employee 101 and his supervisor is equals to 104, and here you have 104 and then his supervisor is 110. To find out the first name of the employee and first name of the supervisor, then I am joining E dot super SSN is equals to S dot super SSN, SSN. Then these two tuples are joined, and then from this I am picking up E dot F name. Now E dot F name is equals to what? Suppose if we have a name called A, and then if he has a name same attribute and his name is X, then E dot F name is equals to, I am referring to this value for this tuple, the name is equals to A, and then I am selecting for the joined tuple S dot F name, it is X. That is why this gives you for employee A, his name is A and then the supervisor's name is equals to X. This is how we can perform the self join, and if you are performing a self join, then if you need more than one instance of the same relation, then you will be giving a alias names, that is you can name them with the different distinct names and then apply the join conditions in the where clause accordingly. Then select SSN from employee. This will retrieve all SSN values from the employee table. And one important point is, in relational algebra, if you apply select condition, the duplicates are eliminated, but in SQL the duplicates are not eliminated by default. Okay, that is very important point to be noted. Then select SSN and dname from employee department. That means for every employee I would like to know his SSN, that is social security number, and the department name. For this I need to join tuples spread across two tables, but here I am not specifying any where clause. If you look at the previous examples, I have clearly mentioned the join condition in the where clause, but here in this example I do not have a where clause join condition. Then what is going to happen? If you do not have a join condition, it is equivalent to employee cross product department, that is the meaning. That means the Cartesian product of these two tables is taken, that is every tuple in employee table is joined with every tuple in department table, and from that it is going to extract the SSN and then department name. That is why if you do not specify a join condition, it is nothing but a Cartesian product. And there is a wildcard, that is if I say select star from employee where DNO is equals to 5, it gives you all the attributes from employee table. Here, because I am not specifying the attributes list that need to be displayed in the result, I am just specifying it as star, meaning that give me all the attribute values for from employee table. And for what kind of tuples? Here I am specifying only for those tuples where the value under DNO column is equals to 5. Then we can specify all, that means it will give all the values. Select select salary from employee, meaning that it will give you the list of salaries that may include duplicates also, and this query both are same, whether you use the keyword all or you do not use, still the result will be the same. But if you want to see only the distinct values in the result, then you may need to use the keyword the distinct. You will have to use the keyword distinct. And here suppose there is employee 101, 104, 110 and 114. The salary is 9K, 8K, 9K and 8K here. Then if you use the first one, it will give all the values including duplicates. And if you want to eliminate duplicates, then you will have to use the keyword distinct. That will give you only 9K and then 8K, because these are the distinct values available in the set, available in this list. Then we can use the following operations like union, except and intersection. That is, except means that is, this is for set theoretic operations. The union operation can be performed using the keyword union in SQL. The difference operation, that is the minus operation, can be performed using except keyword. The intersection can be performed using intersect keyword. For example, let us assume that I have an employee table. I have employee ID, employee name, and then department number and age. I have tuples like this 101, 105, 108 and 110. A, B, C, D are the names. He works with department number 5, 6, 5 and then 8, and age is equals to 28 and then age is equals to 35 and 32 and then 19. Now I would like to figure out all the employee numbers and the names who are working with department number 5 at the same time, whose age is greater than 30. I can write it in one way like this, that is select EID, ename from employee where DNO is equals to 5, that is the first condition that need to be satisfied, and age is greater than 30, put a semicolon. This is very important point. All SQL statements, they end with a semicolon, and if you look at any SQL statement, whatever complexity it may have, still it will have only one semicolon, okay, and it may have nested queries, that is a different story, but still it will have only one semicolon. I can retrieve this like this. The result is going to be like this, employee ID and then ename. In this case, the employees who are working with department number 5 and then whose age is more than 30, there is only one employee, that is 108, and whose name is C. That is the result. The same same data can be retrieved using union operation. How I can do it? You get the list of employee IDs and then names, okay, who are working with department number 5. This is the first set. That is, what is the result of this? Select employee ID ename from EMP where DNO is equals to 5. This gives you 101, name is A. The second one is 108, name is C. In the second set, what I am doing? Select employee ID and employee name for those employees whose age is equals to greater than 30. This set is going to be this one and this one, 105 whose name is B and 108 whose name is C. These are the two sets. Now if you perform union of these two, in this case it cannot be union. Here I need to use the intersection. That is, I can use the keyword intersect here. If you say union, can you imagine now? Yeah, I will be using the intersect keyword. So if you take the intersection of these two, what is the intersection? Only this one, 108. That means if I wish to retrieve the employees who are working with department number 5 as well as having age greater than 30, I will have to use the keyword intersect. Okay, then it will give me first how I am writing this query. Yeah, of course this is not union, this is going to be intersect is the keyword that need to be used here. So the first set, the first query will give you the set of employees who are working with department number 5. The second set will give you the employees who are having age greater than 30. Then if you perform intersect operation, that will give you the employee IDs and the names who are working with the department number 5 and then who are of age greater than 30. Suppose if I am considering the same query without intersect union, what could be the result? It is nothing but the list of employees and then employee names who are either working with the department number 5 or having age greater than 30. That is the meaning. So it is union. That means if an employee is working with 5 or if he is having the age greater than 30, all such employees, employee IDs and then names will be displayed in the result. That is the meaning of this union. And if I use intersection, that is going to be the intersection of two sets, and if I am using the except condition, then it is going to be the minus operation or difference operation between two sets. In this example, the first query, subquery is going to give you one set, the second subquery is going to give you another set, and then I will be using either union or intersection or difference operators. Then substring comparison can be done in SQL. The characters, that is all strings in SQL, are enclosed in single quotes. Any string that should be enclosed in single quote. The character percentage replaces an arbitrary number of characters, and a character underscore replaces a single character. For example, if I want to retrieve all employees whose address is in Houston, Texas, that means I am not worried about what is his street, what is his door number, all those things, what is the zip code, but I know that I want all the names of the employees, first names of the employees who belong to Houston, Texas, and under this condition it is guaranteed that his address will definitely contain a substring Houston, Texas, and before that what is there I am not worried, and after that what should be there, what can be there, I don't know. So that's why in that case I can use wildcard, that is the before this Houston, Texas I can put a percentage, meaning that it can be prefixed by any substring, and after this Texas I am using percentage, meaning that it can be suffixed by any substring. But still, if an address contains a substring Houston, Texas, for such addresses, for such employees, give me the first name. Okay, this is using percentage as a character to match the substrings, substring comparison, to perform substring comparison. The percentage replaces an arbitrary number of characters, not one character. So before this there can be any number of characters, after this there can be any number of characters, but you want to check for any one single character. That means if you want to replace one single character, then you will definitely use the underscore, definitely use underscore. That means if I say that get me all employees who have born in 19 underscore underscore, meaning that what? It will give you all employees. I don't bother whatever is the character here and here, but it should be prefixed with 19, meaning that what? All the employees who are born in 1900s will be showed up in the result. So the underscore will replace one single character, whereas the percentage will replace any number of arbitrary characters. And then to retrieve, we can also use some simple arithmetic operations in the statements, that is to retrieve the resulting salaries. If every employee working in accounts department, accounts project is given a 10% rise, the management would like to know what could be the salaries of the employees who are working with the accounts department, and if their salary is hiked by 10%. So the salary, if it is 10% hike, the salary should be multiplied by a factor 1.1. So that's why select first name, comma, salary multiplied by 1.1 from employee, works on and project, because if you would like to know the employees who are working with the project accounts, then first you should go to works on table, there you will find the project number, then go to project table where you can find the project name. So that's why I will be needing employee table, works on table and then project table to get the result for this requirement. And in where clause I will specify where, how to join this. Now I am trying to join multiple tables, employee, works on and then project. There should be some commonality among these tables using which I can join the tuples which are spread across these tables. So first I can join employee with works on, because what is the commonality? SSN in employee table is referred by ESSN in works on table, which tells which employee is working on what project. So SSN in employee table is equal to ESSN. There is no ambiguity, because these tables, though they have similar kind of attributes with same domain, but the attribute names are going to be same. So there is no ambiguity. And the second condition is PNO in project table, PNO in works on table should be equal to P number in project table. Then with these two join conditions, I have joined the tuples across employee, works on, and then project table. From the resultant tuples, I will pick up only those tuples where the P name is going to be accounts. Only for such tuples which satisfy this condition, I will pick up F name and then pick up salary and then multiply that with 1.1 and then show it in the result. With this, it is only whatever calculations or computations have been done, they are only temporarily done, and that are only for the purpose of showing the result. The original database is not touched at all. Then we can also use the retrieve all employees in department 5 whose salary is between 30,000 and 40,000 including these boundary values. Hence, I have a support feature. By using the keyword between, I can specify this. Select star, that means get all the attributes of employees from which table? Employee table, where the department, the first condition is department number should be 5 and the salary between 30,000 and 40,000. This is one condition and this is the second condition. This condition clearly says that the salary of an employee should be between 30,000 and 40,000. That means it is greater than or equal to 30,000 and less than or equal to 40,000. That is the meaning. That also includes the boundary values. And similarly, I can also specify the order by clause. If you want to, suppose the employee details are there in the employee table, and if you want to see the results in a specific order, then you can use this order by clause. The default ordering of the results is ascending order, and we can specify the keyword descending if we wish to see the results in a descending order based on the value of a particular attribute. For example, select F name, DNO, age from employee table where salary is greater than 30,000 and order by DNO. Suppose if you have employees working with the department number 10, 20 and 30, and then if you apply this on employee table, it will first pick up, this is the where clause condition, that is it will first identify the tuples where the salary is greater than 30,000. Of course, one additional 0 is there. So when salary is greater than 30,000, and then for such tuples it will show up first name, DNO and age in a specific order. What is the order? It will arrange the results in a order, in a ascending order based on the value of DNO. That means first all the employees working with 10 will appear, then all the employees working with 20 will appear, then 30. That is going to be the result after ordering based on some attribute. And similarly, if you wish, you can order the results based on in descending order also. If you look at this example, I am selecting employee ID, employee name, age and salary from employee table. Here what I am trying to do is, I am trying to order them by both employee name as well as age. It is also possible. And in the previous example, we have ordered the result based on only one attribute value in ascending order. By default it is ascending order, but I would like to arrange the results based on two column values. First column is ename, it should be in ascending order, and the second column value should be age, it should be in descending order. This is how we can specify the ordering of the results in SQL statements. In this lecture session, we discussed about the history of SQL, and SQL was introduced by IBM, and the first version was introduced in 1970s. It was called as SQL. Later it is named as SQL, and later on the standards organizations like ANSI and ISO came into picture, joined hands to standardize that, and the current version of SQL is SQL 3, or it is called as SQL 99. And also SQL supports very beautiful features like DDL, DML, transaction management support, embedded SQL support and all these things. That also we have discussed. And we have seen how to create tables, that is DDL commands, using which we can create or define the structure of the database. We can create the tables, we can alter the structure of the tables, we can add new constraints, we can add columns as and when it is required. We can also drop some constraints or some features or of a table using this drop command. And then we started discussing about how to set foreign keys if there is a dependent table and then foreign parent table, and how to set foreign keys if there is a circular dependency between the tables or relations. Then we started discussing about the DML statements. What is the basic form of the SQL statement? which contains select, from, where clause. The select here in SQL is totally different from the select operation in relational algebra. And we have seen some features or some examples how to write some queries where we can join the tuples which are spread across multiple tables. Let us stop here. In the next session also we will continue with the other important features of SQL query language, and then we will also discuss about the views in SQL. Thank you very much.